In this video, we'll be exploring Git case studies through real-world examples of Git usage in major projects. By examining how different organizations and communities utilize Git, we can gain insights into effective version control strategies and workflows. Let's begin with the Linux kernel. Git was created by Linus Torvalds specifically for the Linux kernel development. It involves thousands of contributors worldwide. The Linux kernel uses a pull request workflow via email. It employs a maintainer model with subsystem branches. Here's the Linux kernel typical contribution workflow. First, use git clone to clone the repository. Then use git checkout to create a new branch for your feature. After this, make changes, then commit with git commit sm followed by a descriptive commit message. Finally, generate a patch for email submission using git format patch. Let's look at some Linux kernel Git statistics. It has more than 1 million commits, more than 15,000 contributors, the repository size is around 3 gigabytes, and it has been in use since 2005. Now let's take a look at React, which is Facebook's open-source user interface library. React uses GitHub Flow with pull requests. It uses extensive continuous integration and continuous deployment automation with GitHub Actions. It uses semantic versioning with detailed release notes. Canary releases are used for early testing. Here is the React contribution workflow. First, fork the repository on GitHub. Second, create a feature branch with a descriptive name. Third, submit a pull request with a detailed description. Fourth, pass automated tests and code reviews. Fifth, the core team merges with squash commits. The React project typical pull request workflow involves first cloning the repository. Then change the directory to React. After this, create a checkout with the name fix/component issue. After making the required changes, run yarn test. Commit the changes with a message fix. Resolve component rendering issue. Finally, push the changes to the remote repository. Now let's discuss Python. Python migrated from Mercurial to Git in 2017. It uses GitHub for contributions and issue tracking. Core developers have direct push access. Python Enhancement Proposals or PEP process is used for major changes. Protected branches with required reviews are used. Here is the migration timeline. In 2014, there were initial discussions about migration. In 2015, PEP 481 proposed Git migration. In 2016, there was test migration and workflow planning. In February 2017, the official migration to GitHub was completed. The migration challenges included converting more than 100,000 Mercurial commits to Git, preserving commit history and attribution, training core developers on the Git workflow, and updating continuous integration and continuous deployment pipelines and automation. Now let's take a look at Kubernetes. Kubernetes is Google's container orchestration platform. It is one of the largest open-source projects. It uses a special interest groups, also known as SIGs, structure. It uses a sophisticated branching strategy. It uses extensive automation with PROW continuous integration system. Here's the SIG-based contribution model. First, contributors join relevant special interest groups. Second, SIG members review pull requests in their domain. Third, approvals are required from SIG maintainers. Fourth, release teams coordinate across SIGs. The Kubernetes pull request workflow with bot commands looks like this. After making changes and pushing to fork, some common bot commands are used in pull request comments /kindbug, /signetwork, /assign@reviewer, /lgtm, /approve. Let's discuss VS Code. VS Code is Microsoft's open-source code editor. VS Code has a monthly release cycle with iteration plans. It uses feature branches with an endgame process. It uses insiders builds for early testing. It uses automated issue management with bots. Here's the VS Code release process. It involves planning, development, endgame, and release phases. Let's discuss the VS Code branch strategy. The main branch is always releasable. For feature development, create a new branch named username/featurename. For release branch creation, create a new branch named release/1.xx and create a git tag 1.xx.0. Now let's explore TensorFlow. TensorFlow is Google's machine learning framework. It has a monorepo structure with multiple projects. It has synchronized releases across components. It involves extensive use of automation and bots. It manages contributions from diverse teams. Here's the TensorFlow monorepo structure. It has a TensorFlow folder. Inside that it contains core/python/light/js/examples/tools/models/ folders. The contribution workflow highlights are as follows. Contributor License Agreement or CLA is required. Automated testing across platforms and devices is done. Special interest groups or SIGs are used for domain expertise. Synchronized versioning across all components. Nightly builds and continuous integration. Let's explore GitLab. GitLab develops on GitLab itself. GitLab has a monthly release cycle on the 22nd of each month. It has a public issue tracker and roadmap. It uses a single main branch with feature flags. It maintains transparent development metrics. GitLab uses its own platform to develop itself, providing a real-world test environment for new features. The benefits of this are as follows. Real-world testing, faster feedback cycles, better user empathy, showcase capabilities. The feature flag workflow is as follows. Develop features behind feature flags in the main branch, deploy to production with features disabled, enable features gradually for testing groups, roll out to all users when stable, and remove feature flag code in a future release. Here are the key takeaways from these Git case studies. Git adapts to different project needs, from email-based patches to pull requests to feature flags. Projects like Kubernetes and TensorFlow demonstrate Git's ability to handle massive codebases with thousands of contributors. All major projects leverage automation with Git hooks, continuous integration and continuous deployment pipelines, and bots to maintain quality and velocity. Different projects implement various governance structures while using the same Git tools. Public repositories, commit histories, and issue trackers create accountability and enable community participation. Code review processes, automated testing, and branch protection rules ensure high-quality contributions across projects. Git's flexibility allows each project to develop unique workflows that match their specific needs, team structure, and release cadence, while maintaining the core benefits of distributed version control. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.